So our proposed question is, just before 6 p.m., students enter the classroom to find Mr. Feast dead of an apparent homicide. At 6 p.m., the temperature of the body is 80 degrees, while at 7 p.m. it is 75 degrees. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? Now that we have read the question, we can extrapolate the important information. And that would be that at 6 p.m., the body was at a temperature of 80 degrees, that at 7 p.m. the body was at a temperature of 75 degrees, and the room was kept at a constant temperature of 70 degrees. To solve for time of death, we must first solve for K. K represents the rate at which the body cools down as time goes by. We can do this by plugging in our given variables into Newton's law of cooling. We were told that at 6 p.m. the body was at 80 degrees. We plug that in to our object temperature. We were told that at 7 p.m. the body was at 75 degrees, and we plug that in on the left-hand side of the equation. There is a 1 hour difference between 6 p.m. and 7 p.m., therefore we plug that in as T. We were told that the room temperature was 70 degrees, and therefore we use it as our ambient temperature. This leaves us with K as our only unknown. Once we have plugged in all our variables into the equation, this is what it will look like. Our first objective is to get e to the negative k onto one side. Once we do this, we need to use natural log in order to eliminate e and be able to solve for negative k. Once we have negative k on one side, we must divide by negative 1 since we are looking for k and not negative k. Once we do this and plug this into a calculator, we'll receive this as our answer. Since this number is a bit overwhelming, it'll be to our advantage to store it into the calculator in order to improve our accuracy and minimize errors. Now that we have solved for negative k, we can begin to solve for the time that it has elapsed from time of death to discovery. 98.6 degrees is the body temperature. Even though this was not given to us in the problem, we know this to be the last temperature of the body. Therefore, it goes into the object. 80 degrees is the temperature of the body at 6 p.m. and therefore goes into the left-hand side of the equation because it is the temperature, the time of discovery. We can then plug in K, the number we solved for in the previous equation. The room temperature is still 7 degrees, therefore we use it as our ambient temperature. This leaves us with T as our only unknown. This is what our equation will look like once all the variables are plugged in. Again, our objective is to get e to the negative kt onto one side. Once we do this, we'll have to use natural log in order to eliminate e and be able to solve for t. Now we'll have to divide by negative k in order to be able to solve for t. Now keep in mind that k is stored in our calculator as a value. Be sure to use that when calculating. Once we finish calculating this, we'll come out with 1.5 hours is equivalent to t. Now keep in mind we have rounded this number to the nearest tenth. Now what does 1.5 hours mean? Well, this number represents the time that has passed since time of death. Now keep in mind that in the previous equation we used 80 degrees. This was the time of the body at 6 p.m. Therefore, time of death equals 6 p.m. minus t. I found it easier to convert 1.5 hours into minutes. Once you do this, you get 90 degrees. Therefore, our time of death equation becomes 6 p.m. minus 90 minutes. Therefore, time of death equals 4:30 p.m.